Okay, still on our Maths 112, but still in lesson 2. Today we are going to be seeing, in this class, we're going to be seeing case 2, which is derivative of logarithm functions, exponential functions, and parametric functions. First, we start with logarithm functions. So I would like to make this note for logarithm functions. So I'm starting with logarithm functions. When we say logarithm functions, we are talking about normal log, So we have two log. We have log to base e and we have log to base a. Okay, you have to know that log to base e x is the same thing as ln x, but log to base a x is not ln x. These two things should be noted, that log to base e is the same thing as ln x, but log to base a is not the same thing as ln x. Okay, so the next thing we want to look into now is how to differentiate this logarithm function so that when we are asked in exams, we can be able to do that. So I'm going to give us two ways, the normal solving and the shortcut solving, so that you can be able to vary yourself whenever you have problems like this. So the first one, let's see example 1. They asked me that y is equals to log e to base x, and they asked me to find the y, the x. So I want you to see what I'm going to do, because from the answer of what we are going to do, then we can now get the shortcut to this solution, to this problem. Okay, if we have log to base e, log x to base e. So what I'm going to do is that, note first that logarithm functions are subject to chain rule. Logarithm functions are subject to chain rule. So I have solution. I will say let u equals to x, so that my du over dx becomes what? 1. In that same way, I'm going to say that y becomes log u to base e. Log u to base e, so that the y over dx becomes 1 over u log e to base e. Observe what I've done here. If I differentiate log u to base e, I'll have 1 over u log e to base e. Now, log e to base e is 1. So I'm going to be having here now that my dy dx becomes du over dx times dy over du. And this will produce 1 times 1 over u times 1. Remember I said log to base e, log e to base e is 1. And this will produce 1 over u, which is the same thing as 1 over x. So if I differentiate log to base e x, I will get 1 over x. If I differentiate log to base e x, I will get 1 over x. Okay, we go to another example to show that again. Okay, let me see. If I'm given y x to base a, I should differentiate, I should find the y, the x. If this be the case now, remember that this one is log to base a. It's not log to base e, it's log to base a now. So what I'm going to do here now is I will say let u equals to x, so that my du over dx becomes 1. In that same vein, y becomes log, I've called this so u to base a. Then my dy over du will give me 1 over u times log, okay, 1 over u log e a. You see, when I differentiate log u to base a, I have 1 over u log e a. Now, Log e to base a cannot be, it's not 1. So this will not go away as 1. So my dy over dx becomes du over dx times the y over du. This will produce du dx is 1 times dy du is 1 over u log to base e a. So that will produce 1 over u log to base e a, which is finally 1 over x log to base e a. Now, if you observe something, when the base is a, it appears at the end of the day. When the base is e, it only gave us only 1 over x. These are the two things you should observe in solving this. So when I differentiate log to base a x, I have log 1 over x log to base e a. So at this point, we are going to observe something now. So let me show us something now. Remember, when we started, we said that y equals to log x base e. And they asked me to find the y dx for this. Now, my shortcut now, which is my method 2, will now be, this is a function here. Hope you know that. So this is a function. And I know that this is the same thing as ln x. So they can say y equals to ln x, or they can say y equals to log base e x. So what I'm going to do, I'm more interested in the function. So I will say if this is function is x, differentiate x, we have what? 1. Then put dash under, bring back the function, and that is my final answer. I hope you understand that. This is a function, differentiate x, you have 1, then bring back the x. The other one, we have that y equals to log x to base a. They asked me to find the y dx. Now, the function here is still a. So if I differentiate x, the function here is still x. If I differentiate x, I have 1, then I still have my log, my 1 over x. But then because it is to base a, I will not forget to add log to e to base a. Final answer. I believe you have seen the two ways we have solved this. In the first number, we're using the chain rule, and the second, we're using the shortcut. So let's go into more deep examples under logarithm. Let's go into more deep examples under logarithm. I have, okay. Let's see this. I call this example 3. They gave me that I should say that y equals to log to base e 4x minus 1 all squared. Okay, if I have this as a question, now what I'm going to do here is, remember, if I want to take the chain rule where I will say let u equals to 4x minus 1 all squared, so that my du over dx becomes, I'm going to use what I call inside-outside rule to solve for this chain function. Remember, so I will have, I drop my 2, 4x minus 1 raised to power 2 minus 1, 1, so that I'm going to be having, differentiate 4x minus 1, I have 4. 4 times 2, that is, I have 2 times 4. Then I still have 4x minus 1 raised to power 1. What did I do here? I dropped my 2. I wrote the function down. I minus 1 from the 2. Now, if I differentiate 4x minus 1, I will have 4. Use that derivative to multiply what is outside, which will give me 2 times 4, which is 8. Then this becomes 8 into 4x minus 1. 8 into 4x minus 1, which is the same thing as 8 times 4. That is 32. That will give us 32x minus 8. So if you differentiate this, you're going to be having this. So this becomes our du dx. Then the question turns to y equals to log u to base e. so that my dy over du becomes 1 over u log e to base e. You get that? First one, we call this, the whole of this thing, our u. The whole of it, our u. When we call it u, we get our du dx to be this. Then we now call, the question becomes y equals to log u to base e. And when we differentiate log u to base e, we have 1 over u log e to base e. Now, the next thing we are supposed to do now is to now find our dy dx. Okay, I'll bring that here. My dy dx now, which is dy over du times du over dx. That will give me dy du is 1u. Remember that. Okay, let me still continue that, times 32x plus, okay, minus 8. Okay, this over this is 1. So I have 32x minus 8 times 1 over u, which is same as 32x minus 8 over u. But remember that your u is this. So I'm going to be having 32x minus 8 over u, 4x minus 1 all square. Final answer. So if you observe what we have done here, when we differentiated this logarithm function, we got this. Now, you see, if we are to apply the shortcut, let me clean this. Observe this answer. You see, it's going to just be me like, this is a function. If I differentiate this function, I'm going to be having 32x minus 8. Then I put dash, bring back this function under it, all squared. Final answer. Do you see that? That means when I have to deal with a logarithm function, I'm more interested in the function. If I can differentiate the function, then I'll have my way out, especially when the question is in OBJ format, or just dash, German OBJ dash, write your answer. Hope you understand. You see, this answer and this are barely the same. They are just the same. Okay, let's take one more example under logarithm function. That's example 3. Let's go for example 4. I think I have an example 4 here. I have example 4. Y equals to log to base a sine x over cos x. So I'll be using the short form now. Solution. I need to differentiate this. So for me to differentiate that, I will have v du minus u dv over v squared. And if you use that for differentiating, you are going to be having, my v is cos x into, if I differentiate sine x, I will have cos x minus my u is sine x. If I differentiate cos x, I'll have minus sine x all over cos squared x. I believe we still have that idea from other lessons. This will give me cos squared x plus sine squared x over cos squared x. Okay, then this will give me 1 over cos squared x. Remember that 1 over cos squared x is the same thing as sec squared x. So if I differentiate this, I will have this. So therefore, my dy over dx for this is, differentiate this, I have sec squared x over, then I bring this one down, sine x over cos x, which can also be written as cos x sec squared x over sine x. Final answer. Cos x sec squared x over sine x. This can also be simplified as, if you have decided to write it this way, 1 over cos squared x divided by, that is, using, instead of writing this now, I'm writing 1 over cos squared x, then divided by sine x over cos x. This becomes 1 over cos squared x times cos x over sine x. I believe you understand what we are doing there. So, there's 2 cos x here, there's 1 cos x here. So this will take away one of these, leaving with 1 over cos x times 1 over sine x, which will basically give me 1 over cos x sine x, another answer. So this can serve as an answer. This can also serve as an answer. So that is what we are trying to say here. So if I differentiate this, I will have this. But then we are not through. This is to base, the logarithm is to base a. So this my answer will have something. This my answer will have log e to base a. This one we also have log e to base a. You know why? Because our base is a constant. Our base is a constant. Okay, that is for example 4. Take one more example and we'll say goodbye to logarithm function. Just one more example. I believe the idea has been gotten for logarithm function. Take one more example there. Look for something better here. Let's look at this, that they said example 5. Y equals to log 1 plus x over 1 minus x, that is to base e. If they didn't write anything under, that means to base e. This is the same thing as saying ln 1 plus x over 1 minus x. These two questions are the same. So using the shortcut method, if I differentiate this, I will know. So I think we have done this before. If you differentiate this, you're going to have 2 over 1 plus x all squared. Therefore, now my dy over dx will give me, differential of this is this, so I'm going to have 2 over 1 plus x all squared, then divided by 1 plus x over 1 minus x. That is just it. So what I'm going to be doing here now is this becomes 2 over 1 plus x all squared times 1 minus x over 1 plus x. I believe. Then the multiplication. Now I have 1 plus x, 1. Assuming this was to be up, there will be cancellation, but it's down, so they can't cancel themselves. This will produce 2 into 1 plus x over 1 plus x all raised to power 3 cube of it now. I think, okay, this is 1 minus x, then over 1 plus x raised to power 3. So differentiate this, you have this, then divide it by the same function, and you are here. It is to base e, so there will not be log, so that is a final answer. I think we have done 5 examples for logarithm functions, and I believe that is very okay. So I'm going to drop us with an assignment to do. That will be in the example 6. Example 6. I want us to try this. Y equals to log x over 1 plus sine x. Looking at this question, you see that it's a very simple question because we have dealt with it. Let me give us int. Okay, so here I'm going to be using v du minus u dv over v squared. Okay, so that my v is 1 plus sine x. Then if I differentiate u, I will have 1 over x. Remember, okay, minus u log x. Then v. If I differentiate this v, I'll be having, if I differentiate sine x, I will having cos x. When you differentiate sine x, you have cos x. Differentiate cos x, you have minus sine x. So I'll be having cos x here. Okay, all over 1 plus sine x all squared. So at this point, what you are going to do is, we're going to look at this. This will give me 1 plus sine x over x minus cos x log x all over 1 plus sine x all squared. Now, you are going to first of all simplify the numerator by saying take LCM of this, which if you do that, it will give you LCM is x. X in x is 1, so I have 1 plus sine x then this will give me x, which will give me minus x into cos x log x. That is what I have for the numerator there. I took the LCM, which is x. X in x, 1. 1 times this gave me this. X in 1 is 1. 1 times x in 1 is x. 1 times x times this will give me this. So opening it up, so we are going to be having, this will be 1 plus sine x minus x cos x log x over x. Then I can now say divided by 1 plus sine x all squared over 1. If you change this divide to times, you are going to be having 1 plus sine x minus x cos x log x over x times 1 over 1 plus sine x all squared. So we have this times this and this times this. Let's finish it up here. So this times this will give me 1 plus sine x minus x cos x log x over x into 1 plus sine x all squared. Okay, looking at this, you see that this, nothing can cancel out, and I think we can leave our final answer that way. So I've already solved the assignment I wanted to give us. So, but then I will leave us with this. That is example 7. Given that y is equals to, okay, ln root of 1 plus x. And now I want you to give me, find the y, the x, okay? You're going to do this as an assignment, and let me see your answer in the comment section, okay? So with this, we close it up for logarithm function. We go to exponential function. Now we are going to be looking at 2.2. Okay, you know, our logarithm was 2.1. So exponential function should be 2.2. Now, when we talk about exponential function, we have 2 types of exponential function. We have the normal exponential function, and we have the general exponential function. So this one is a normal exponential function. Now note, if you differentiate an exponential function, you get an exponential function. Okay, so what I mean by the normal exponential function, example, if I have that y is equals to exponential x. Now, this, when you see this type of e, the big E carrying a function at the end, we call it a normal exponential function. So remember I said if you differentiate an exponential function, you will also get an exponential function. So let's see something now. If y is equals to exponential x, I should find the y dx. So I will say, I will also use chain rule. I will say, let u equals to x. Du dx is 1. Then the question becomes y equals to exponential u, so that my du over dx still becomes exponential u. If I differentiate exponential function, I have an exponential function. So my dy over dx becomes du dx times dy du. Okay? So that I'm going to be having du dx is 1 times dy du is exponential u. This times this will still give me exponential u. But I know that u is what? U is x. So that I'm going to be having the y over the x becomes exponential what? X. You see, when we differentiate an exponential function, we get an exponential function. But in the real sense, it's not that if they give you question, you return the question as the answer. But you see how we say when we differentiate exponential function, we still get an exponential function. Let's advance into more examples so that we can see that. That is example 1. Let us pick example 2. If y is equals to exponential minus 3 x minus 1, then also I should find the y dx. Now look at this example. Y equals to this is an exponential function. So if I'm to find the y dx here, I will say let u equals to minus 3x minus 1. My du over dx becomes, if I differentiate minus 3, I have minus 3. Okay, in that sense, y becomes exponential u. So that my dy over du becomes exponential u also. At that point now, I'm going to be having my dy over dx becomes du over dx times dy over du. And this will give me minus 3 times exponential u, which will give me minus 3 into exponential u is minus 3 x plus 1. And this is my final answer. Now, if you observe what we did here and what we did here, it will now take us to the shortcut, the short form of doing it. So I will clean this and show us what I mean. Now, watch what I'm going to do now. Just like we did in logarithm function, if I have that y is equals to exponential x, and they ask me to find the y over dx, what I'm going to do is, you see that this x is being carried by, this is a function here, and this e makes it an exponential function. Just like when we have log x to base e, this is a log person, why this is the function. So if you have exponential x, this is the exponential person, why this is the what? Function. So we're always interested in the function. So the function here is x. See what I'm going to do now. Differentiate x, I have 1. Then the whole of the question, put it here, which will give me this final answer. I believe you understand what I did. Differentiate the function, then multiply it with the whole of the question. Let me do the other one. They gave us that y equals to exponential minus 3x minus 1. And they asked me to find the y dx. This was the example 2. If I differentiate this, I have minus 3. Then I will jam it with the whole of the question again. And that's my final answer. I believe you understand what I've done here. So for speed's sake, when you have exponential function and you're asked to differentiate the function, then multiply it by the whole of the question. That will work out. Let's see more examples to drive this point home. If I have something like this, that y equals to exponential sine 4x. This is a point, and they asked me to find the y dx here. So very simple for me because I'm going to use the short form. I'm going to be saying that differentiate sine 4x. If I'm to differentiate sine 4x, remember it's going to be differentiate 4x, 4, differentiate sine, you have cos, then bring back 4x. If you don't know what I did here, go back to our lesson one, our lesson on trig function. Our lesson 1 should be that, on trig function. If I have sine 4x to differentiate, I differentiate 4x, I have 4. Differentiate sine, I have cos, then bring back 4x. Remember, if you differentiate sine x, you have cos x. If you differentiate cos x, you have minus sine x. So at that point, if I differentiate this, I have this, then I multiply it with the whole of the question again. And that becomes my final